In this video we'll make some logics to detect if any of the sensors are faulty. The way we're going to detect that is if sensor 2, for example, is active, sensor 1 should also be. Since if the water level is above here, it's definitely above here as well, unless there's a fault on the sensor. So if a sensor is true, the sensor below it has to be true as well. If there's a sensor fault, let's stop all the pumps. Let's let that be the action of it, which is the same as we did for the low sensor. If there's not enough water, we stop the pumps, and if there's a sensor fault, we're also going to stop the pumps. So let's make a new FB, call it sensor fault, and let's try ladder this time. So we have the 5 sensors. We'll use those as input. And the output being the alarm. And let's add a temporary struct. The temporary boolean like that. So let's add some networks just to make some room. Last thing we're gonna do is see if we can get a coil. There we go. Nope. There we go. The last thing we'll do is set the output, which is gonna be a copy. See if we can find a contact. There we go. It's going to be a copy of the temporary memory. And as we said, if a sensor is high, the one below it needs to be high as well. So let's start. Let's just see what we can get out of it. Start from the top, which is sensor 5, that's the one on top. If sensor 5, do we have a parallel? Let's just do it in a series. If sensor 5, over here, and not sensor 4, the one below it, then there's a fault. And we have a parallel. Here we go. Is this loud? Nope. How about this? It's easy to imagine how much easier this would be using text, but it's graphical for a reason, the only reason being it's easier for humans to understand later. It's not necessarily easier to maintain, it's not necessarily easier to develop, but it has its use. Maybe this one. Come on. Well, that's something. How about now? Nope. Starting to get annoying. Fuck it. We could expand all of the sensor faults into separate networks, but then we would need separate storages. Let's just do that instead of figuring out how to make that branch. Oh, that's number five. I could make these videos shorter by just rehearsing and recording several times, but that takes more of my time, and well, I don't want to. So if you could find your fast forward button, just use that one. There we go. So if any of these, then let's just tidy this up. If sensor 4 and not sensor 3, then there's a fault on, technically there's a fault on sensor 3, let's correct that later. 3 and 2. So obviously we will not be able to check if the top sensor is okay, since there's no sensor above that one. So here there's a fault on sensor 1 and 2, 3, 4. We don't need this one. Can we get a parallel? 3, 2, 1. So if there's a fault on sensor 1, 2, 3 or 4, then we set the output high, otherwise it's low. It's a fault on sensor 4 if sensor 5, the one above it, is true and sensor 4 is not, and so on. Let's hope that works. Let's see here, we did not use any memory here either, so we could have just settled for a function, but use the function block. So let's use that. Add it here. Delete all this. Just give it a default name. Then we need to connect it all. We have that sensor 1, that's over here. Let's give it some room. And then we need the remaining. Don't really remember what they're called, so maybe we should check. That was the wrong one. Let's check. Level indicator 2, 3, 4 and level alarm high 5. High 5. Two, 3, 4, 5. Level alarm high 5. Level indicator 4. Level indicator 3. Here we go, and then we'll add it to the same pin as the low level alarm. Also, we'll add the functionality of this MB block so we can block or suppress or latch the fault. Let's add an MB. Call that one for smart sensor logic. Did we need any parameters from that one? Let's give it a name. That's useful. We do not need to invert it. Let's latch it. Why not? Let's put a delay on it. And there's the input. Now we're gonna put it on the same pin as this one, so we'll just use an OR. Earlier we could block this alarm here. We could also block it in this template. We can block the safeguardings. Now we will be having two faults into one OR for the safeguarding. So if we didn't have the option of blocking in each individual alarm, we could only block on the SPE template and we would block everything. But now we can block each individual alarm if we want, and we can block all of them if we want to do that. Then add it to the others. There we go. So now we have our sensor fault logics and an MB connected to it, and it's going to stop the pumps if there's a fault. And let's add a visualization for it. There's the one, and then map. The signal is going to need SSL. We need the operator station statuses, so we can display those, and the commands from the operator station, and the parameters. All done. So the simulator is running. There's no low level alarm. There's no alarm on the smart sensor logic. Let's start a pump. That pump is running. Let's go to the simulator. It's at 29%. Level switch low 1 is true and level indicator 2 is true. So if we were to simulate this one going false while this one is still true, there should be an error. So let's do that. Let's force LSL1 to false. Let's close and open again. This one. And then we're gonna force that one. There's an alarm. So well, the pump stopped, but then again there's a low level. What's that about? Well, there is a low level, obviously, because the sensor, the low level sensor is low. Sorry. So we could use the information here. We know that the lowest sensor is faulty, so we could do something about this, that this one shouldn't be active when we know the sensor is something wrong with it. But at least the alarm showed up. Let's see how the logic looks. x5 is not true, x4 is not true, x3 is not true, x2 is true, but x1 is not true. So there's the fault. There is a fault on number 1. Looks alright. So let's see what we can do about this. If there's a fault on sensor 1, we could block the alarm from the low level, since we don't really know anything about the low level sensor if it's faulty. We could suppress it, so we just ignore it completely. So let's use suppression. We don't care about the low level alarm if the low level sensor is faulty. And if we know the low level sensor is faulty, we'll do this exactly same thing. We're gonna stop the pumps, so we're not altering any functionality, we're just altering the display actually. So let's suppress this one if the sensor is faulty. Yes, we could make this tidier by using these connection marks. Who cares? There we go. Nope. That's better. So, if there's a sensor fault on any sensor, we should ignore this one. It's good enough. We could make it specific that if there is a fault on the lowest sensor, which we would know, then use that signal instead. But now, just if there's any fault on any sensor, then we ignore this one. Let's see if it's accepting that. So now it's automatically being suppressed, the low level sensor. The BX here, the input is true, so there is a fault detected, but there's no alarm, there's no latched alarm, nothing, because it's all suppressed. It is suppressed because there is a fault on the sensors. So if we block this one, then we ignore the fault on the sensor, the detected fault on the sensor logic, and this is active again, which is wrong. It's wrong because we're simulating it to be wrong. We forced it false. So the water level is above level indicator 3, but we said that the lowest sensor is false to mess with it. So it seems like it's working. So if we now restore the fault, this fault should go away, and also should this. It's automatically suppressed by this one, so all of it should go away, and we just need to reset it. Let's just unforce all of it. There we go. This one is latched, so we need to reset it. There we go. And just to test again, let's try and empty the tank. Is this going to be enough? No, that's not going to be enough. Let's tweak the manual valve. And the low level sensor still works when there's no interference from the smart sensor logic. So that's how to one example of how to program a sensor fault into your MPA program.